Hi everyone, welcome to this video. So far I explained each step of how to use Etab and from the beginning to analysis and result. So in this video, I will show you the complete process again by using a small project to story building. This is one of my story build project that I do for reinforced concrete. So let's try this analysis in Etab. So first of all, when we get the uh, plan and the model by architecture, and then we use the architecture information to uh, assume our section, our location of the beam, the column, our structural system. So we can assume them and model in Revit first, and then we can export to Etab or other program to analyze. So in this project, I already model my model in Revit. I already placed the beam, the column, and so on in Revit. So I will just go to modify in Etab. So that's the way that we can also export directly to Etab. But if you go quite complicated, so if I have time in the future, I will show this process. But for now, we will draw manually in Etab. So before we go to draw, this is the criteria or the project property that we're going to do. So we have the design code and material property, section property, and load. So let's use this information and uh, do our analysis model in Etab. So let's go to Etab now and new project, new model, and say the unit. So my unit will be in metric. So I use metric MKS and select the standard for design. After that, choose the grid system. We can choose in blank or grid only. So anything we can modify it. Okay. So the first step is we need to modify our grid system based on our model. So let's go to change the unit, check the unit, 2 meter, and okay, and do right click and add or modify grid. Okay, let's modify the height or the story first. So click on modify story, and this is the default one. So we are going to check our model, go elevation. So here there will be 4 level. So in this Revit, I use different level for the first floor and the ground level, but this just because of the beam. So when we analyze, we just assume that they are the same level, and the footing is called the pier. The column that connect the footing to the first floor is called the pier. So it's 1 meter under the ground. And then first floor is 4 meter high. Second floor is 3 meter, 3.3 meter. And second floor to the rooftop is 2 meter. So I'll name this to be first floor, second floor, this one is roof and rooftop. Okay, so The elevation for the base one is -1, and then the first floor is 1. So from base to first floor, the height is 1. So we can see here now the first floor is in the ground floor, zero elevation. And then second floor 4 meter, 3.3 and 2. Okay, so now we get the elevation and also the height here. So that's it. And modify the grid X and Y. So uh, let's go first floor. So in Revit, the in our model here, the dimension is in the spacing term, but we can use change them into the coordinate system by choosing a point. So I will choose the bottom left corner here to be the original point, and then uh, to the top, to the north is uh, y direction, and from left to right is x direction. So we can uh, set this to 0 and then just plus the distance to make it coordinate. Okay, so just capture and then go to Etab and modify them. So for x, okay, for now is okay first. Okay, and now we get the grid already. I want to check for the secondary grid. Okay, I think for now it's okay. I just use the main grid first. So when I draw the beam, if I find where I should put the beam, I can add a new grid. So now let's go. We already finished the grid drawing. So next step is to define the section and the material before we do the modeling. So now to set the section and material, just go to check our property. So we're gonna use strength design method, and FC prime of concrete is 240 kc. Steel rebar grade is SR24 and SD40, and slab section 12 for RC slab and plank slab 10 centimeter, and we also have the wall. Okay, so for the beam and column, we can assume the section first. Now, first of all, select the define material, and then they have the default material here. We can use directly. So I will also create the steel roof. So I will modify this steel. I will just name it to make. I just name it for me to see easier. And then okay, this is okay. The grade, the strength of this, the yielding strength is about 3,500 KAC. I forgot to change the unit. Let's change to KAC, kilogram per centimeter square. Okay, now go define again material and concrete. We can modify it. Now I will just say FC prime 240 KSC, and then go to modify material and change this one to be 240. Okay, next for the rebar, just modify it, and I'll name this to be SR24 and modify. So the property for rebar SR24 is 200, 2,400 and 3,900 SD40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. 40. and add a copy of this and name it to be SD40. Okay, I think we have all the material that we need already. This one is the tendon, I think. Okay, tendon we don't need, so just leave it. Now click OK. And next to define the member, so go define section, and then let's define the frame first. So let's define uh, the steel first. So I will create a steel roof. So in my Revit structure, I didn't create a roof yet. So I will just create in in Etabs the steel roof. So let's import new section and choose. I will use the tube section for steel, and then we can select anyone here. We can select. Actually, if you have the steel table, you can select there, and I will just select anyone here. Okay, and I want to modify it to be my uh, preferred section. So just modify it and convert to user defined. So now I want to modify to be 10, 10 times 10, sorry, 10 times 5 times 0.3 centimeter, and change this to 10, 5, 0.3. Okay, and modify at another one. So sometimes when we analyze our section may be too small, so we may create the extra one in order to make it analyze faster. We can change immediately. So let's set this to be 12 times 6 times 0.4 centimeter. Is about the depth, the width, and the thickness. You For this one, you should use the steel table. Next, we define the concrete. So to create the concrete section, I will just use the default one, the define one here already, and just modify them. So choose concrete beam and modify it. So I will name it to be B1 and use the material to be concrete. And next, change the section to be 40 times 20 and modify report. So this one use only moment, bending moment, and longitudinal bar use SD40. For setup or confinement, we can use SR24. So that's it. Oh, I think I want to change the cover to be only 4 centimeter. Okay, so just use 4 centimeter. Now click OK. And I add another one. Okay. Next column, concrete column, we use this one and modify it. And this one we need because we this is a assume section, so we should decide this section. So just change to decide section and cover. Okay, number of I think this one just change it. This one you can change or not. It's okay. We can modify later because this just assume section. Okay, and then just add a copy. Okay, now we have the section already. Next is to define the slab. So we have the slab we have RC slab and plank slab. So RC slab we will use for some area that contact to the ground or to the water, and plank slab we can use for any slab that above the ground or not contact to water. So now let's define slab section slab, and we they are already defined default to one, so we can modify the precast slab or plank slab and just name it plank and change the slab thickness to be 10 centimeter and membrane. Okay, this membrane and one way slab. Next, define this one. So this one I will name it to be RC slab. RC slab one. So RC slab you can divide two type. So the first one will be shell thin, and the second is membrane. So shell, if you design the slab, if you want to design the slab together with your frame, or you wish to design the slab in Etabs here, you should use shell thin. But if you just want to model the slab and use as a dead load, so just to apply the load, so just use membrane. So my slab I already design, assume that I already design uh, outside, and I just want to apply to the structure by dead load and to transfer the load. So I will just use membrane. So that means the slab will not take any moment from the beam. Now let's use this to be 12. Okay, that's it. Now choose the material. Okay, that's it. Now, okay. So one more step is for the roof. The roof is supposed to be metal sheet or some roof material. But in Etab, there is no real real material for the roof unless it is reinforced concrete roof. But in our model, it is a metal sheet, so we can add some we can create a slab, like we can consider it as a metal sheet. So let's add new material. Our name is to be sheet, and sheet supposed to be steel and used as a membrane. And now uh, okay, we don't need to use one way slab, one way special. Actually sheet is one way, but I want just to use as to transfer the load. So I will name it. I don't need to use this one. So we need to change the thickness, maybe just very thin. So 1 centimeter. And most importantly, I want to use the sheet to be salvageless. So modifier, just click modifier show and change the weight to be 0. So why the metal sheet doesn't have the weight? The weight assume that we just assume the metal sheet salvage already and apply as a dead load. So this slab we can ignore the salvage. Okay, I think that's okay. Okay, now we have all the slab already. Now click OK. Okay, we are ready to draw now. So first of all, I will draw the column first. So let's check. So the column, the scatter around here, but uh, you can draw manually one by one. But I will use the quick method. Quick column, draw quick column, and select all the grid, and the column will automatic draw in the grid. And I just go to delete where I don't want. So uh, the roof, let's say the roof I don't want yet. Oh, need to escape first. Delete the roof. Okay, the roof, and then some column here. I don't need. Change to all story, and the column middle. Okay, now let's go to check where else we don't need. Okay, this one. Okay, let's go to first floor. So this grid has column, this grid has column, this one no column, three column, four column. Okay, okay, I think it's correct. The next, to draw the beam, I will. Oh, I forgot to assign them to be. Uh, let's assign them first to be. The section should be C1. Assume that it's C1 first. Okay. Next, draw beam. So again, I will use. Okay, maybe just use draw manually. Uh, Go to first floor. We can click the quick tool draw or draw manually. So let's try quick tool. Just select all and then delete the thing that we don't want. Okay. I missed the grid for the stair beam, so I'll just go modify grid. I need to check what is the distance. Okay, the distance is 1.4 meter from D. So just calculate it. 1.4 meter from X direction, D 779.1. So I just create another one. I'll name this to be D prime and 900. Okay, now I have the grid for the stair beam. So just draw stair beam. Okay, again, I forget to assign frame section to be beam one already. So okay, it's okay. We can modify it later. Uh, Next, go to second floor. Second floor. We supposed to use B1. Okay, and draw all again. Then just delete the beam that we don't want. Let me check second floor. One beam here. One beam here. One beam here. Oh, this one also. We need to add new grid. So it will be about 2 meters from original in y direction. And I think there's one here. 3 meters from line E. Okay, draw the beam. So we'll have one beam here, and then one beam here. Okay, this one more beam, and this one more beam. Oh, also this one. I think we have the opening here. So the distance is 2.85. 2.85. Let's add y direction. This one is okay. Okay, now I think we already complete. Let's go 3D. First floor. Okay, I think first floor I missed one beam here. Okay, so earlier some member I didn't use as a concrete beam. So again, let's change the section to be concrete first. Click select and object type and select all beam. Select and assign to be section beam one. Now let's use beam one first. Okay, next we need to create a slab. So slab second floor. Second floor and then door slab and choose to be plank slab. So the area that contact to water we need to use RC slab. For example, okay, this area is a toilet area and also this one. So we need to use RC slab. So for now I will draw the area that not contact to water first. Plank slab. Okay, the first and second floor we complete. Uh, Before we go to the roof, I want to set the order member here to be let's set the beam and column assignment first. So let's go to the beam. Select let's do this here and view by section property. Let's do extrusion. Try. Okay, this is our model. This is how it look. This for concrete structure only. We haven't modeled the steel structure, the roof. Actually, I missed one column here. There is a column X here. So let's go to elevation and line A. Hmm? It's not line A. It's line one, I think. Okay, line one here, and I'll draw one column. Choose C1 and draw this column. Okay. Okay. Correct. Next. Okay, the next step is to draw the roof. So the roof is a steel roof, so we need to use the steel section. Uh, let's draw the column or the king post first. So the king post, I will use the quick tool draw column and change the section to be the section that we define, which is let's use 10 times 10 and then select the grid. Okay, it automatic drop. Okay, next to create the triangular shape for the roof, let's go to elevation. Okay, this elevation. So the middle of this one, there's no grid yet. I will create the middle, add grid. in y direction. The hip of is a hip roof, so it should be in y direction. The middle of this is 4.4. Okay, next is to create the bracing. So okay, this is our roof. So I will just copy to the rest. Use the coordinate. So from here to here. So I will copy this triangle hip to the rest of the column. So just go and edit, select the frame and edit, uh, replicate linear, and then use this is the x direction. So x, the first one is 3.6 uh, in the unit of centimeter. So 360. Okay, right. And then next, select previous one, and then copy to 2.2 meter. Okay, next, uh, to sorry, it's not 2.2. Let's undo first. It should be 4.1. Previous select 4.1. Oh, just select this 4.1, and then previous select 3.9. Okay, now, okay, this one delete. Okay, the extension here, go select and object type. Oh no, select property. Oh no, non-material. select property section, and then select the frame and this one, select, and column, this one, select. Now go edit frame and divide frame, break intersection. Okay, now can delete. Okay, okay, next go to frame again, plan view, roof. Okay, now we need to create the uh how to call start beam along the edge of this, and we're gonna use the bigger section. Let's use this one. Okay, it's complete now, and only the roof left. So the roof, let's use the extrusion. Let's select. Okay, select all this, and then dry frame. Okay, now go edit and extrude frame tool shell. And now let's use uh, x direction. So n is 0 and x from here to here is 11. This one. Oh, only. Okay. No, no, it's not correct. Okay, again. Okay, select roof and assign shell, slab section, and sheet. Okay, let me define. Okay, our model is complete now. So the next step is to assign the frame and the joint, how we should make them connect, like simply support or fixed support, and so on. So now let's go to the modify the joint first. So for the joint, the connection, joint here, select all, and then go assign joint, restraint, and change to fix all. Okay. Next, for the column, I think is just fixed. And for the beam, for concrete beam, they also supposed to be fixed. But for secondary beam, we can use as a simply support beam. So now let's go to check secondary beam, first floor. Okay, the beam that connect to the column, I will consider as a main beam. So they're gonna be fixed support. For the beam that not contact to the column, I will consider them as a secondary beam. For example, this one, uh, this one. Okay, I will consider them to be pin support. So assign frame, release fixity, and release apply. Okay. This one should be join. Okay, second floor. Second floor. This one. This one. This one. Pin support. Okay. Hmm. I think I missed the column here. So this one should have the column. Okay, good now. Okay, for the steel beam, I will select. mm, Okay, for the steel, I will use as simply supported only. So assign frame release. Okay, and this one. Okay, draw. Okay. Uh, Now we already assign the beam, the column, and now let's assign the slab. The slab, um, first floor. First floor, since it is just RC slab, so the load will distribute correctly to the floor. But now go to precast slab. You can see the direction here. The precast slab will transfer the load in the direction of this. So if we don't want to it to transfer the load like this, we can change. So I will change this load. Mm, I will change the load to be the location of this to be 90 degree. The direction. Okay, the load transfer like this, and also this one 90 degree. Okay, for this one, it need to be changed like this because the beam only exists in here. Next, this one too. This one same. This one should be changed to the main direction. It's better. Change to the main beam. Okay, this one. Okay, I think this one is okay. Mm, okay, okay, now it's good. It's about the load transfer. Okay, now I think we are ready. Now let's save the model first. Save, control save, and name it to be uh, design model. Okay, Save. Okay, we already a model our model almost complete, and we assign every member that we want already. For example, we some member we want as simply support, and some member we want to be fixed. We already do that. Only few more step for the state. Okay, let's go to the state. For the okay, this is the state. This one is for the state channel. So the state, I don't recommend you to analyze in a tab. You can do it, but I think the load will not it's quite complicated. So if you don't know how to assign correctly, the load will not transfer like we want. So I will introduce you the method how to make it uh, the load like you want. So we just calculate the day load, live load of the state separately, and then just apply into the model. So uh, actually, the first floor and second floor they must have the landing of the stair, and there will be a beam between to support the landing. So now let's create the uh, beam first. So to create the beam in the middle, just select two column, and choose go edit or use the edit frame here, and divide the frame into two member. Okay, now if you click the column, you will see here it separate into two frame, and then just draw a beam. I choose beam one, and just draw the beam into these two column. Right. Okay, maybe go elevation view, go to elevation view and elevation F. Okay, this is the stair. So we already divide the frame. Now let's just draw the beam for between here. Okay, the first floor and second floor, and use this to be simply support. Assign frame, delete. Okay, and then connect the column again. So column should be continuous here. Just join frame. Okay, now we already get for the second floor. There is no stair. Second floor to the top, there is no stair. So just one beam. Okay, now we have the beam already. So we just apply the load of the stair into that beam. The next one I want to talk is about the roof. So the roof when we draw, maybe if you draw it one sheet by one sheet, it's okay. But if you draw like the whole sheet like this, so you should separate the sheet into the frame, divide to the frame. To do this, just go edit, select the sheet, and then edit shell, divide shell, and then use the divide quadrilaterals here and choose intersect with frame. So apply. Okay, now let's go select. Oh, uh, I think it's because I forgot to select. Okay, again, select all the frame. Let's go like this. Select by object type. The triangular frame is called the bracing. So select, or you can select the member by the section. So select the shell and the member that you want to separate. So edit shell, divide shell, and intersect with the frame that we select. Okay, now let's check. Okay, now it already divide into the shell. Okay, now good. The next step is if we just apply the shell like this membrane into the structure, uh, it based on my experience, this one does not transfer correctly to the beam. It does not transfer the load to the beam. So if we want to make it transfer to the beam, we should separate, divide into the small element. So why I say that it does not transfer to the beam? Because the shell here will transfer the load directly to the column. So it's not that we want to transfer to the beam or the frame here first, and before it transfer to the column. So uh, let's select let's select the material again. I want to select the wall. This is considered as the wall. I don't know why. It's like inclined slab, and then go divide, edit again, divide shell, and divide shell. Now let's divide the shell here to be smaller section, to be very small section. You can divide into two member for one area, one panel here. You can divide into two member, three member is okay. Let's use not this one anymore. Use cookie. Okay, use this one. Divide by area. So uh, so if you want two-way slab, you can use the different number. But if you want only transfer the load only to one beam, so for example, this slab, this roof will transfer the load to this frame and transfer the load to this frame only. So I will use one relation only and multiply by this one. Maybe I divide into 5. Now let's try. Okay, you can see here the shell will separate into uh, element like this, and they will transfer the load into one way. Sometimes it may be switch. Just do the trial and error. Okay, and now our model is complete. I think if we find something error, we can modify it later. Uh, Now let's run first. Try to run. Let's try to run to check the initial deformation. Change the graphic to be graphic X. Okay, it's faster. So we can see here the deformation. This one is very large. Mm, okay, but it doesn't mean that it failed. Okay, okay. So there's no warning message, so it's okay. That means our model is complete. Okay. Next step is to apply the load. So to apply the load, we need to define the load first. So we have three different load type. So they give us the live load, uh, super dead load, and wind load in the zone C. So and the dead load we need to calculate from the wall. For example, the internal wall is 10 centimeter, the external wall is 12 centimeter. So we just calculate the dead load by the unit weight. Okay, now let's modify it. Now let's define the load pattern. So load Dead load and live load already given. Let's define super dead load, super dead, and add, and then win load, win x, win load. There are two directions, so win x and win y, and change this to win. And I will use the auto win load. So I use the standard, this standard, and add. And for the same for y direction, okay, just add. And let's modify the standard. So we want to apply the load in the area unit. So just use the exposure from frame and area object, and choose including shell object. And now this one let's set to be default, and this one zone C, and this one, okay, the unit, this is normal, and the exposure height. So our base is under the ground, so there will be no exposure. Just use from the first floor to the rooftop. Now click OK. Same for Y direction. Change to shell object, and then zone C and first floor. Okay. Now everything okay. Next, let's modify the load combination. Okay. Load combination. Let's add new load combination. Okay. So I will define the load for steel first. Mm, this one is concrete. Okay, concrete. Mm, dead load plus live load. Okay, the first load combination I will use is I will use uh, ACI code for load combination. So uh, let's highlight. The first one is dead load plus live load. Second one is dead load, wind load, and live load. Only that one. So only two. So this one dead load factor. Uh, how much? 1.2, 1.6. And this one super dead load. No, super dead load, live load. 1.2, 1.2. I name this. Okay, combo one. Add new combo. Combo two. Combo two. Dead load. 1.2. Super live. Win Y. Win X. 1.2. 1. 1.6. Okay. Add new combo. Okay. And for the steel, mm, for the steel, okay. For the steel, we can modify it too, but if we want to use the standard one, we can add the default one and steel frame. Now click, and we can also modify it. click OK. So we just select uh, some, just modify dead load, super dead load. This one we don't need, and this one check dead load, live load. We don't need. Okay, actually we can use all of them. Okay, so the program will auto select for us for the maximum one. Now let's create another one. Sometimes it's very complicated to choose one by one. So let's create another combo one, and I'll name it this to be envelope and change to be envelope. So just select. Okay, just select the load combination that we want. Okay, I think the rest no need. Okay, just like this. So this one is the program determined for us. If we don't want to use them, we can delete them. Okay, just click OK. Next step is to decide assign the load for the floor. Now let's select object type. I will select all the floor. Okay, all the floor, and then go assign shell load uniform. Assign super day load first. So super day load. Oh, let's change the unit first. Then go assign shell load uniform and super date 120 for all gravity load only. Okay, and then live load. Select again. Live load 200. Okay. Next, for the roof wall. So the roof, there's no super dead load, so they only live load. So for the roof, live load is just 50 kilogram per square meter. Okay, I think that's it. Okay, next is about the frame. So the frame we will assign like a uh, dead load from the wall. So the wall, the wall there will be the uh, internal wall and external wall. So we just calculate the dead load of each floor and multiply by the height, and there will be the light load. For example, the first floor height is 4 meter, and exterior wall just use the unit weight times the height and the thickness. So uh, we will get the force on the beam. So now let's apply. I'll select. Let's go to plan view and select the first floor. Okay, select beam, select. Oh no, it's not correct like this. Mm, okay, let's go to first floor. This select first. So we assign the exterior wall first. So the exterior wall. This one there's no wall because it's an entrance. This one also no wall. So just select this. Okay, now let's go to exterior wall first floor, 4 meter. So it will be 921.6 kilogram per square meter per meter. Aside frame load, um, frame load, and use dead load because the wall is dead load. And 921.6 meter is applied. Okay, in the direction of gravity. And then select the interior wall. Interior wall. Some wall might not be exactly in the beam, but we can assume them to be in the beam. Okay, so interior wall is uh, 768 kilogram per meter. Apply. Okay, now move to second floor. Second floor exterior wall. Exterior wall 760.32. And then interior wall 633.6. Okay, uh, that's it. For the roof, there's nothing. Okay, go to 3D. Okay, now we get the load already. The next is to apply the wind load. So at the wind load, we need to apply as auto load. Auto load. So for now, we don't model the wall on here. We need to create some area that can take the wind pressure. So to do that, we just create an imaginary wall. The wall that there is no property, is only the area. Let's go to and let's check where is the our wall. So I will go to build grid first. Okay, so this area is a entrance, so there is no wall here. The wall will be in the inside one. So this is grid one. And we change the property to be known. Okay, let's clear display assignment and then draw the wall. So okay, next we apply the load for the apply the wind load. So for the wind load, they will be the windward side and leeward side. So I will select this as the windward side in the X. Okay, the front one is the, let's say is the windward side. So just select all this and then go to select beam, deselect, and column, also deselect. So now only the also try not select. Okay, only the shell selected now, and then also this side should be inside. Okay, inside. Let's go to elevation. This is the line 2. Okay, okay. Select the wall and 3D again, and then go assign wind load, shell load, wind coefficient, and this one is in a, if the wind come, it should be in a y direction. So y, and then coefficient wind watt is 0.8. Now just apply. Okay. Next for leeward, just go to elevation again. Go to elevation 3. Apply. Select the wall and elevation 4. Select all wall. Okay. Okay. Now assign leeward. So leeward is 0.5. Change to leeward. Okay. That's it. And the next is go to the X, Y direction. So now we're gonna apply the load to this direction in the X direction. So assume this is the windward side and the other is the leeward side. So this is line A, elevation A, click and select all the wall. And now assign to be windward. Change to X, apply. Okay. And then elevation E, also elevation B, I think. C. We have the small area there. Okay, select this area and then elevation D, no, nothing. Elevation E, okay, select the wall. Okay, and then elevation F. Okay, now go 3D. Okay, so we already select the area. Now apply lever. Okay, we complete. Okay, so now we already complete the load assignment. Next step is just to analyze. Okay, now it's time to analyze. Uh, to analyze, just go to analysis and set load to run and run every load except model load. Click do not run. Okay, now run now. Okay, this is the deformation due to dead load only. So now let's go to, I want to hide the grid first, and I want to see the extrusion, but we don't want to see the wall. So the shell that, the wall that doesn't have the material or the imaginary wall, just apply. Okay, now this is the deform shape. Wow, so large deformation here, but it's okay. Let's go to display and deform shape, change to, okay, this dead load and live load. Let's draw contour too. Contour, okay, this live load. Hmm? Why there is no deform shape for live load? And how about wind load? This is the wind load in X direction and wind load in Y direction. Okay, okay, this is the deform shape. This is just how to check uh, visually, but I think why there's no live load. It's so little. So the live load is very little. Okay, why they don't deform the same? Because the span is different. Okay, okay. Let's try load combination. Load, dead load, and live load. Okay, these are dead load and live load. And then uh, we load. Mm, okay, okay. Oh, I think I forget to apply the load for the stair. Okay, now let's go to apply the load for the stair. I want to hide the wall. Just hide the wall, the no shell, no shell. Okay, apply. Okay, now let's apply the load for the stair load. Mm. So the stair is thickness is 15 centimeter. So we just calculate the lead load and live load on the stair, and then combine them into load combination. You will get this to be the dead load. Okay, I think I think I make mistake here. The live load should have the factor 2. Now let's live load. I think I should calculate separately for this one. Mm, Okay, so for day load is about 800. Mm. Now select the stair beam. So this is the stair, and this is the stair beam. Not this one. Could be this one. Okay, select the stair beam and the stair beam under. Okay, now go to assign frame load. So this one will be 840 for day load, including super day load and previous select, and live load is how much? Live load 100 times the area by 3 divided by 2. So it will be the live load will be 350 kilogram per minute. Now just apply. Okay, now we could just run again. Okay, let's go extrusion. Wow, this is very much lot of load here. Let's go to check the moment and shear. So press F8. I will create another window. Okay, this one just use elevation. Oh, okay, moment diagram. Oh, no extrusion. Okay, this is the moment and shear diagram. Also 3D. Okay, shear moment diagram. Still very small compared to the concrete, and the largest moment is here. And check this. Okay, now we already analysis complete. Uh, One more step is if you don't want to see the offset length here, if you want to see the full length for the moment and shear diagram, we can go to set the offset length. Okay, let's go to set the offset length. Unlock the model first. Okay. Okay, now select all, and then go frame assign, and offset length change to be 0, 0. Okay, now can go to analyze again. Okay, so our model complete. We already applied the load, and let's do the analysis. Let's check the result. So let's run. Okay, so this is the deformation. Uh, Actually, the slab deformation in the slab. Uh, you can see that there is no deformation in the slab. There is still a straight line because we use the membrane. So the deformation is not considered in the membrane. However, the beam and the column, they will have the deformation. So now let's check moment display shear force. Let's check support first. Reaction. So I will check all. Let's use combo for. Let's use envelope. Wow, so much. There are moment in every direction. Combo one. Dead load, live load only. Okay, this dead load and live load. So I think the middle one supposed to have the maximum load. Around 30 ton, 30 to 40 ton. Okay, well, we can see in the table form. Okay, and uh, okay, and then we can check like this. Okay, this is how to check the uh, reaction. Next, let's see the moment, share moment diagram. That's what we interested in. And check combo one. Combo one is just dead load and live load. Okay, no value. Okay, this is the moment and shear diagram of the structure. Mm. And if you want to check the axial force for the column, okay, this is the axial force. So you can see that the column in the middle show the larger diagram for axial force. Okay, we can also check the steel column, but the axial force very small. Uh, okay, so let's check the shear moment diagram for this one. Very small because it's just 50 kilogram per square meter. Okay, so I think it's okay now. Next, the analysis result is clear already. If you want to just use the analysis result for your design, you can just go to display and table, and then the first one you need to select is the model information, such as how you define your load, how do you define your material, and so on. And if you don't want, it's okay. The next is the analysis result. So if you want the output to be uh, to be reaction or shear moment diagram, we can select here. So run information, no. Joy output here is about the reaction. So we can click and click the joy reaction here. We can try this, I don't know, joy design reaction. And then next, element output here is like frame output. So frame, that means beam and column. So we just click into frame and choose only element force. We are not choose the joy force. Oh, bracing, yes. Bracing is the incline frame. And joy, we don't need joy. For joy force, maybe if we design for seismic, we need to check how to design the joy force too. And I think that's all we need if we just want the analysis result. So this one, I think no need to show. And clear all. Okay, just select um the first three combination. Now let's okay. Okay, you can see here now is the element force for the beam. So there will be the location and then the axial load, shear, shear in minor axis and major axis, torsion, moment, and so on. So the important one is shear and moment and axial force here. Check column, bracing, bracing for our roof, like the truss or the incline member, we will classify as bracing. And the column. Okay, so you can export this file to Excel and you can modify it and select the uh, column or beam that you want to design or try reaction. Okay, this maybe for deciding putting. We need to use the joy reaction here. Okay, so uh, for now I don't want to stop here yet. I want to design in the use the program to design. So to do that, our analysis is complete now. Next is to go to design. So just click design and then design concrete or steel. So now I think I will design the concrete first. Let me design the steel first. Okay, the steel. We just need to select all the steel. Okay, so before that, for now, design we don't need the slab anymore. So I just close them. I not delete them, but just close them. Okay, so just hide them. Okay, now I only see the beam and the column. So I will design the steel first. So select all the steel and then go design and steel frame. First, revise the preference. So I'll design based on AISC 2016. So this one is okay. And I'll change this to be ordinary moment frame. So, or we can, this one is a seismic moment frame. This one is intermediate and this ordinary. So maybe we use the intermediate. I'll assume that our region is not the very severe region due to earthquake and wind. So we just use intermediate. So the more if you use ordinary, if you the load will be less, and if you use SMS SMF, That means our our section will be you. We need a bigger section to resist the load. So I'll use the medium one and zone C, and then load factor. Okay, I think the rest is okay. If you use this for your project, I recommend you to look every parameter carefully, so you know what you are designing for. So okay, now I just set them to be default one. Click OK. Next, design again, still, and override. Now, so I will design them very first. Omega, this is the allowable, and connection. Okay, I don't design connection yet. Okay. So deflection, we can check the deflection too. I'll change this to be 240, 240. Okay, the rest I think I'll just set as it is. So click OK. Now let's start checking. Still, and okay, need to define load first. Uh, we can use all, actually we can use all of this, but I think I just use the one I define. Uh, okay, win load, live load, dead load, and win load only. Okay, actually this one also there are some similar to my combination too, but they just have more option. Okay, now click OK, and this side again. Now start this side check. Okay, so we can see here now we can define them by the color. So if they are in the blue zone, that means it's quite safe. Green zone also safe, but when it comes to yellow to red, it might be too small. Okay, so now I think our section is all okay. Uh, this is the minimum that we decide already, but due to the small load, that's why our member the minimum already passed. Okay, so sometimes if it's not fast, you just click on the member and right click on it. So and then just go to override. So override, and now just change the section. Okay, when body is maybe too small, you can change to bigger one. So my one I think is too big. If I define the other section, I might use the smaller one. For example, this one, I change to the smaller one. And now click OK. Okay, it will automatic change. And it still pass. So it's okay. No, the still already finished. The still already passed. Next, to decide the concrete, just select all the concrete. Concrete. Select all the concrete and then decide. And then override to check the standard that we decide for. Okay, I think everything here is fine. Okay, I recommend you to check every factor correctly, so you will know what you decide for. Okay, so for me, let's say this is just a example. So I assume that everything is okay here. Click OK, and now next to decide again. Decide combination, or let's do override first. Override. So this one too is the same like uh, before. If we use sway special, That means our structure need more reinforcement. And if we use intermediate, it will need less. And if we use ordinary, that means it just uh, like normal structure. Just for example, normal structure. What is normal structure? Normal structure is like to resist dead load and live load only. So for sway and sway special, they usually design for seismic and wind load. So I'll choose sway intermediate. And then everything here is okay. So torsion, eccentricity, I think I will not consider for eccentricity. Okay, now just click OK. And then let's select the load combination. Okay, again, I will just use uh, 3 of these. And maybe we can add the envelope too. Envelope is the same like 3 of these. Okay, click. Now let's check. Let's check. Start checking. Okay. Change the unit. Let's change the unit to be centimeter and kilogram. Okay, now let's go to elevation. Okay, here is the I think it's better the floor plan. The roof, there's nothing because it's just steel. Now, second floor, we can see the reinforcement here. Okay, the bottom number means the reinforcement for the bottom beam. Sorry, for the beam in the bottom, and the upper one is the reinforcement in the top one, top beam. So, uh, okay. So for the beam, if you just show the reinforcement like this, some reinforcement maybe is too small. Let's click in. Oh, I think this one is steel. Okay, it's not correct. Okay, anyway, this one is a steel. I need to change it. Okay, okay, this uh reinforcement that we need. So sometimes the beam might need too much reinforcement. So for example, this one is like 8.6 centi square meter for steel. So we might need to change to bigger section. So just override, click override, and then change this to be B3, I think, the maximum. Now click OK. Okay, now it become less because this one is a very long span beam. So I think it change to bigger section. And now let's go to first floor. Okay, first floor. This one I think is okay. Okay, this one I think also change to the same section. B3. Okay, just make it similar. Okay, now I think everything is okay. We can go to check the column for elevation. Okay, this is the column. Seem like the column is okay. For column is a bit different. Uh, Mm. Okay, you can see here some member for the column. It is too small, it's not pass, especially in the middle one. So you can see the uh, or over S, that means over stress. So we need to change to the bigger section for this one. So let's change to all story. So I will choose this and this to be, let's do override and change to be C2. Let's see on this one, override C2. Okay, now it passed. Now let's check again. Okay, so the column mostly have the small area. That means it just use the minimum reinforcement, 1%. So 1% of the reinforcement. So it just equal to this one, 1% compared to concrete. So assume that our section is just this section is just 20 times 20 centimeter. So if we use only 1%, that means just for the steel area needed just for 4 square centimeter. Okay, so that's it for the design. Uh, okay, for concrete design already finished, we can go to the design result, go to display and show table. Now we need to, if we want the analysis result together, we can just click here and the design data. This the design that we created. So uh, I will just use the steel output. Just use summary and then concrete output summary. Okay, you can see here the design that we use is ACI. Design beam joint. Okay, I will not use the joint. Okay, now let's click OK and see what table we get. Okay, now our table increase and the design one, concrete beam design summary. Why there is no concrete beam fracture design summary? Is it because I don't uh, column? I think wait again. Ah, I need to, okay, first we need to set analysis to last section and then verify all member pass. Where is it? They say one member not pass. Oh, this member not pass. This beam is not pass. So maybe it's too small. So just go right click and then here it show overstress for shear. So we just do override and change this beam to be B2. Click OK. Okay, now it passed already. Now let's go this side again. This side and then verify all pass. Okay, now the this side pass. When this side pass, then let's go table again. I think because I didn't select the load, so select all. Okay, now click OK. Okay, now we can see the beam summary now. Uh, it has the reinforcement detail for shear and moment. So we can export this to Etabs, sorry, to Excel and Excel or Word, like go to file and then just export to wherever you want. Okay, assume that. Okay, let's say go to Excel, export. And let's still decide. Okay, here also have the still decide for us. It check the uh, Excel load and moment ratio. It show all the capacity here. Okay, it's a lot. You need to check one by one. Go to beam design, beam design for envelope. Okay, so there are a lot here. Just check one by one and decide. And so how do you know where is the beam? So just check the unique name here. In Etabs, just unlock the model and then I'll show you again. So this is very important. You should know where is your beam. So just use this to identify. For example, this beam 265, where is it? So it's in the second floor, but the location, where is it? So just remember this number and then uh, go to display here and after assignment. And now for the frame object. Okay, object assignment and frame. Use the unique name. Apply. I think we need to unlock the model in order to see it. Okay. Okay, you see the number here. So number 260 is in the second floor. 265 here. This member, this beam. Okay, we just use this beam. Just remember the number and then go to identify in Etabs. Oh, sorry, in Excel. Okay, this is a table that we export from uh, Etabs. So this is the table for beam. Okay, so you just export one by one. And just delete the table that we don't want. Actually, we can also export every table. And if you want to do the report, maybe just export to Word. Okay. Uh, for I forgot to mention that etab does not really etab does not really show uh, does not really decide the reinforcement for you. It just decide the required area for reinforcement. So so when you have the area for, okay, let's go here. When you have the minimum area here for top and bottom, you just go to select the steel for your beam by yourself. For example, maybe just this one is just 1.77 centimeter square for reinforcement in the top. So you just select two steel minimum. So maybe dB 16 is enough, just like that, and then do the detailing by yourself. Mm. And the same for column. Uh, However, I want to show you the another method how to design in Etabs by selecting the steel by yourself. So to do that, uh, for example, the structural steel in the roof, the structural in the steel in the roof, we can check the capacity directly, and we can check it pass or not. So if it pass, we can use directly the section that we define here. But for concrete is a little bit different. So we need to use these are the assumed section only. So if we want to check uh, our design that it pass or not, we need to create a design section. For example, my beam, I use 2 dB in the top and 2 dB in the bottom, and I want to check that how it pass or not due to the moment, due to the load that we apply. And the same for column. If I just use 4 CTO in 4 corner, it can resist the load or not. Okay, so let's do that. To do that, let's go to define again. Go section. Okay, now let's define the column. Uh, okay, maybe we define C1. So this menu, we need to convert to SD section. Okay, for the column, we need to convert to SD section. Just convert to. Oh no, I think okay, I already convert. Okay, I think we should not convert, we should copy. So it's gonna be different. You can do both, but I think I prefer to copy and still keep this section. So just copy to SD. I'll name this to be C22 and to be checked. Click column type to be checked. So this one we can only use as the column. Okay, just click column and to be checked. And now modify the section designer. Okay, now it look like this. So if we want to change the steel here, for example, I will just right click in the rebar and the material is D40 and the height. Uh, okay, I forgot what is the section. This I think 25 times 25. So maybe 3 meter. I will just increase the uh, covering, and then I'll change the bar to be corner bar to be only 16. Okay, let's do it. This is faster. Just click in one corner and then change the bar here to be just 16 like this, and click apply to all the similar pattern. So apply. Okay, now they become all small. This one should be okay. High bar. Let's use Thai bar to be only 9. Okay, now correct. Okay, now just click OK. Click OK. And then add a copy. Add a copy of this and change to be C 33 and to be check designer. So next I want to increase the section. Just okay, just increase the reinforcement. So right click in this, right click, and then increase the H bar here. So H bar I will use one. Why? Oh, okay, number here change to one. Okay, now you see here if one bar will come up and just click in the bar and modify it to be db 16. Okay, and I'm going to apply for all. Apply. Okay, now you can see the bar will increase. Now click OK. Click OK. I think that's enough. Now how about the beam? The beam we're gonna do the same. Let's change B1 to okay, convert copy to HD section and change to be B11. So for the beam, it is not recommended to do this way because the program only recognize the column, but however, we can also check visually by using this method. Okay, just use because okay, you can see here there's no option for beam. Uh, that's why it is not recommended for beam. So however, we just use for checking, and I think it's okay. Just use for check reinforcement and designer. Okay, there's no. Okay, you can see the beam here. There's no reinforcement. We can add a new reinforcement. So just go to draw and rebar shape, and I will use the rectangular bar. So just click in the center. Okay, now it will come out. And then we know that our section is uh, 40 times 20. So just click in the rebar and change the radius. Okay, the material is HD40 and change the rebar to be, so rebar minus the covering. Covering is let's say 3 meter clear covering. So 40 minus 3 times 2, 6. So it's going to be 34. Height 34. And then width 20 minus 6 is 14. Okay. And then let's check first. Okay, now you can see it. Just right click in the bar and change to be reinforcement, yes. Okay, change reinforcement, yes. And then material SD40 and corner bar. We just use 12. I'll just change one. We can change because here very complicated, maybe very slow. So I'll just change one and then modify later. For H beam, H I also use 1 bar. Okay, okay. Wow, very bad. Change to rebar size. 12. 12. Okay. Why I cannot change the number? Hmm? It's not correct. Okay, again. Maximum bar space. Right click in the step. Okay, let me change again. Corner bar, 12, 12, H bar, 0. I don't know why this has the rebar. What is this? I don't want this. 0. Okay, what is this? Hmm. Maybe we had a copy of 2 already. Okay. Why the still lab so big? Thai bar. Oh, okay. Thai bar just 9. Oh no. Okay, let me do again. Dolly bar. Now click rebar. General material is D40 and Thai bar 9 corner bar. Okay, let's say like this first. And I want to click here, change to be 0, apply for all. Okay, just use the corner bar, dB 12, apply to all. Okay. Why Thai bar still the same? Oh, change here. There's no 9, only 8. Okay, and change this shape to be, change the shape to be 34, 24. Wait, 14. Okay, now, okay, and okay. Hmm, Okay, modify it, add another one. We use the same, but we're uh, gonna add corner bar here to be 1. Oh, diameter is 12. Okay, okay, and add a copy. Now be ชูทูบัตรพร้อม prime for tension reinforcement. Tension reinforcement. So we just uh, delete this one to be 0 and then add to this bottom. So it's gonna be 12 and 1. Okay, that's it. Let's add one more. B 3 3 and let's change the bottom to be 2. Okay, I think this should be prime for the tension and add a copy, and this one to be 3 3 only for tension, and 2, this one 0. Okay, okay, so I think it's okay now, everything. Next, let's go analyze again. Okay, this is the analyze, and then this side, let's select, okay, undeformed shape. Let's select object. Okay, let's select like this first. Select all the object for the concrete, and then select deselect property. I will decide the beam first. Now deselect the column. Okay, now only the beam left, and decide concrete override and change this to be B. Okay, let's say B11 for the normal one first, and okay, and now column. Okay, let's deselect beam. Oh, select again, and beam deselect. Okay, now only column left, and go this side, override, use the section to be C22. Did it pass or not? Okay, now run this side. Okay, so now you can see here it show the capacity of the uh, column. I think I need to decide the beam like this. Okay, this show the capacity. That means the column that we decide is already passed. We can go to elevation and check. If it not pass, it will show the red color and write over stress. Okay, so it all passed. Now I think I will select again the beam. The beam select. No, let's select all the beam and deselect column. Now only the beam left. Go this side, override, and change to B1. Okay. Now click and this side. Combination. Okay. Okay. So for the beam, we can see here there are a lot of red. So that means it some member does not pass. For example, this one. Okay, I will decide this column, this beam. So now it's red. That means it not pass. So we need to. We can also check the demand capacity ratio. Just go this side and then concrete and check information, display information, and use the PMM ratio, apply. Okay, now we can see here, it over 1 already, is 1.9. That means the section cannot resist the load. So we need to select all the member that not pass. For example, okay, I will decide one first. Just click in the one not pass, and we can see the location where it not pass. So it mostly in the middle. So that means not pass the tension steel. So just override and change to a bigger section. So I think I will change to this one. Prime B prime is a tension reinforcement, both tension and compression, but the more steel will be in the tension side. So just click OK and click OK. Now, oh, it's still not passed. So that means I need to create a bigger section too. Uh, okay, for now, right? For now, we can see here the location that not passed is around 2 meters. So maybe let's change another. How about this one? Okay, I run out of section now, but we need to create the bigger section for this one. So how about this one? I think the same. So let's create a bigger section. Let's create a bigger section. Define section. Now let's use B3 and copy to this section. Now be design and to be checked. And draw reinforcement. Choose the center. Okay, now modify this side. 3 reinforcement. Maybe 2. On this side also 2. So now we're gonna use the bigger steel, DB25, and for this side, I will not use any steel. Also this side. Okay, and change the size to be, now our section is 60-30. So we'll change to be, covering is 6 centimeters total. So gonna be 54 and 24. Okay, it fit now. So now let's use this section to check. Okay, be design. Click OK. Now let's go design again. and undeformed shape. And now let's select other beam or the concrete beam and select deselect column or object type column. Deselect. Okay. Now only beam selected and go at this side. Override. Change to be design. This is just I just show the example how to do it. But when you do, you may need to decide properly how many steel and check one by one. So this one I just use one member to check all. Okay, now you can see our member that we decide to be bigger, and now it pass all the uh, load. It pass. We can go to check it, and this the capacity demand ratio is quite a lot. So maybe you decide define the smaller section to check it. Here is like only 10% use. So you may need to we may decide the smaller section or less reinforcement. Okay, so this is one way to check our design section it pass or not. Uh, you may try this method, or if you prefer just to do your hand calculation by using the reinforcement design here that we analyze and design, and you select your own steel, and that's also okay. Okay, that I think it's already complete for this example. So then I explain many way here. You can use any method to check your model. So thank you for watching, and I hope to share you new knowledge about Etabs again. So thank you and see you next time.